Hi everyone, this is question number 22 in circular measure. The diagram shows sector OADC with center O and the radius R. So let's just put down the R. And the angle AOC is given as 2 theta radian. ABC is a semicircle with AC as its diameter. So if AC is the diameter, the center of the semicircle, let's mark it down with P. All right. And these two equal in length because it's the radius for the semicircle. So next we got to show that AC equals to 2R sine theta. Now AC is the chord for the sector AOC. So to find the chord, we use the formula 2R sine angle, half of the angle. The angle is 2 theta. So divide by 2. So 2 and 2 can be simplified. So we have just shown that AC is 2R sine theta. Now let's say we do not know the formula to find the chord. So we derive on our own. So by looking at this isosceles triangle, we know that the symmetrical line will divide this triangle into 2 equal parts. So let's just draw the symmetrical line. So this is 90 degrees here. So the angle will be divided equally into 2. So to this angle theta, R is the hypotenuse. And then the PC is the opposite. Okay, so with O and H, we can apply the trigonometry ratio sine. So sine theta equivalent to PC over the H, yeah? H is R. So PC equals to R sine theta. To find AC, it is double of PC, twice PC. So let's replace the PC with R sine theta. We have just shown that AC is 2R sine theta. So this is the alternative. All right. Now, next, we have to express in terms of R and theta for when we solve the following question, the area of sector OADC. Now let's change to this. So part A, to find the area of OADC, the sector OADC is half R squared theta. So R squared, the theta here is 2 theta. So the 2 can be simplified with a half. So we have R squared theta. So that is the answer because we just need to express our answer in terms of R and theta. That's it. And B, we have to find the area of the segment ADC. So the ADC is this part, the one that I shade in purple. So it will be the area of the sector OADC minus the area of the triangle. So the area of the OADC is R squared theta. The area of the triangle will be half R squared sine theta. In this case, the angle is 2 theta. So we can factorize the R squared. So theta minus half sine 2 theta. So leave this as our answer. C, we have to find the area of the shaded region. Okay, the one that is shaded in the question, not the one by me. So that will be area of the semicircle minus the area of the segment, which we already found in B. Now, the question is how to find the area of the semicircle. Same thing. Its semicircle is also a form of sector. So half R squared theta. Now the theta is pi, but the R basically is half of our AC, isn't it? We already found the AC. So half of the AC, yeah? So we take 2R sine theta divided by 2, and then we got to square this, okay? Using the same formula, half R squared theta. So we found the radius of semicircle and the angle is pi. And minus the area of the segment, which is r squared theta minus, so together, okay, let's just put like this, minus half r squared sine 2 theta. Okay, let's simplify the 2 here. So now we have half r squared sine squared theta times pi. So put the pi in front. And then minus r squared theta plus half r squared sine 2 theta. Okay, so we can leave this as our answer, or we can actually factorize it. Okay, let's factorize by taking out in half r squared. Half r squared. So the first term will left with pi sine squared theta. And the second term, there is no half. I take out the half, so this one I need to put 2 theta, because r squared already taken out. And then plus half r squared I have already taken out, just left with sine 2 theta. So that's it. That's the answer for question number 22.